So we are talking about solving quadratic type trig equations. So what we started talking about yesterday was ones that look like this. Let's see if I can give you one that's a little bit nicer. Nope, not much. Okay, so let's say we've got tangent squared x minus 2 tangent x plus 1 equals 0. Okay, so we're going to talk about how do you solve this. I picked tangent because tangent's the easiest one. So this one, the ones that we talked about yesterday, had two terms in them, where you are subtracting one to the left side or the right side and making it equal 0. This is a 3-term quadratic, okay? And we factor this using regular factoring patterns, just like we did in section 5.1. So if you're like, I can't remember, look back at section 5.1. This is essentially asking you, how would you factor x squared minus 2x plus 1? Like what are the factors for this? So it'd be x minus 1 and x minus 1, right? So over here, when you pull this back into this guy factors to tangent x minus 1 times tangent x minus 1. And then you're back to that same point we were with yesterday's, where you have two things multiplied together, each to equal 0. That means they both have to equal 0. Now, life is really nice for you right now, because what's true about both of those equations? They're the same, so you only have to solve one. But notice you're back to that basic type equation, which is your goal. When you're solving a trig equation, you have to get yourself back to a basic equation, because that's what you know how to solve. Okay, so tangent inverse. Where is tangent inverse of 1? Pi over 4. So it's pi over 4 what? Plus pi k. So that's it. Like, tangent's the easiest one, and you didn't have two equations because both of your two equations are the same. So let's do another one. Okay, let's do 2 cosine squared x minus 5 cosine x plus 2 equals 0. Okay, you can do this however you want. To my brain, I don't like to see this. It's too much, so I go over here and solve the quadratic, or factor the quadratic. Okay, so another review of that. Remember, you have to multiply a times c together. So it has to multiply to 4 and add up to negative 5. So what two things do we have that multiply to 4 and add up to negative 5? Yes, negative 4, negative 1. So bring that back over here. I did that wrong. Crap. Sorry. This is negative 4x. This is negative 1x. Sorry. So it's 2x squared minus 5x plus 2. This gets broken into negative 4x, negative 1x. So 2x squared and x plus 2. So this you gotta pull out. What are you gonna pull out of the first piece? 2x. And then you've got x minus 2. This needs to be an x minus 2 over here. What do you undistribute? Yep. So negative 1 and then x minus 2. So then you have 2x minus 1 and x minus 2. Bring that back over here, because you're solving 2 cosine x minus 1 times cosine x minus 2. Okay, go ahead and do that for me, please. What do you got for your first answer for this one? Pi over 3? Pi over 3. I agree. So pi over 3 plus 2 pi k. What's your second answer for that? Okay, negative pi over 3 plus 2 pi k. Now, come over here, you have cosine x is equal to 2. Cross it out, because cosine never equals 2. So you guys, if you're like, why not? Why not? I want you to think about a graph of cosine. A graph of regular cosine, what's his maximum? 1. What's his minimum? -1. No, -1. So cosine never equals 2. Okay, so it has to be between 1 and -1 if you're going to be able to solve it. So if it's not, just cross it off and you're done. So 2 answers on this one. Okay, one more. I want you guys to try this one all. See if it's the one I gave yesterday. It's not. Try this one all without me yapping at you. Okay, and I will come around, and if you have questions, this is the time to ask them. Okay, there you go. What does so going to just the regular old quadratic bones of this thing, what multiplies to 2 and adds up to -3? Yeah, -2, -1. to think that you factor to 2x minus 1 and x minus 1. So 2 sine x minus 1 times sine x minus 1. So you're solving 2 sine x minus 1 equals 0 and sine x minus 1 equals 0. So if sine x equals 1/2 and sine x is equal to 1, what do you get to solve sine x? What's your answer? Sine x equals 1/2, sorry. Yep, pi over 6. So pi over 6 plus 2 pi k. And your next answer would be? Yep, 5 pi over 6 plus 2 pi k. And then sine x equals 1 would be what? Yeah, pi over 2 plus 2 pi k. If you do pi minus pi over 2, what do you get? Same thing, so don't write it down. There you go. 3 answers on that one. Okay, do you have questions about the factoring kind? Okay, we're going to add one more level to that and then, oh my gosh, stop. Okay, so we talked about this in yesterday's warm-up. So what's the problem here? They're two different things, and I cannot factor anything out because I've got one that's a sine and one that's a cosine. So what we have to do here is we have to switch that sine out with a cosine. Okay? Because the cosines, the second one has to match. Okay? So it has to be cosine. So this guy is the one that drives what everything else has to be. Be really careful here because when you substitute the sign, it becomes something with an addition or subtraction. Cosine squared minus 1. But that is multiplied. They're both multiplied times the 2. So this is 2 cosine squared minus 2 plus 3 cosine x minus 3 equals 0. So then it's 2 cosine squared plus 3 cosine minus 5 equals 0. But once you're done with that, now you're back to doing what we were just doing. Okay? So I don't feel a need to take you through this. So let's just practice the switch part. So let's say we have cotangent squared x plus cosecant squared x minus 7 equals 0. Okay, so just the switching part of it. Javon, why the frown? I know I'm guessing what you're thinking, but tell me what. Yeah, it is.
So you would get a single, you would add cosecants together.
Yes.
And then you're going to do
So in this case, you have actually a choice. You can, because they're both squared, right? So you can substitute either one. You can say, hey, I want to do only cotangent or I want to do only cosecant. So it doesn't matter. So what does the thing say? Oh. The thing says cosecant is, let's see. This is my thing, right? This says cosecant equals 1 plus cotangent. You guys, I'm all about efficiency, which is just a nice way to say I'm lazy about this. I don't want to switch this around. I'm just going to take out the cosecant and replace it with 1 plus cotangent squared. Plus 1 plus cotangent squared is equal to 0. Oh, I forgot my minus 7 in there. So then what do you have when you simplify this? Minus 6 equals 0. Then it's not even a regular factoring. This goes back to the first thing we talked about yesterday, right? Where you add 6, divide by 2, do the square roots. Okay, I'm not going to make you solve that. But I want you to try this one. So I do want you to hear me say, you could have substituted out the cotangent if you wanted. If they're both squared, then you have a choice. So I want you to get this simplified, but you don't have to solve. Okay, what do you get for the final simplified bit? Yep. -1, I think. Okay, I substitute. You also could do this with secant, and you're gonna have something a little bit different. I don't know what you're gonna have. Couldn't tell you right now. But I would substitute secant because secant is a positive. I don't have to rearrange it. It's tangent squared plus 1. So with the 3 in front, that's 3 tangent squared plus 3 minus 2 tangent squared minus 4. So 3 minus 4 is -1. 3 minus 2 is +1. There's tangent. Okay. If you substituted the tangent out and you did secant instead, you have 3 secant squared minus 2 times tangent is secant squared minus 1. So you would have 3 secant squared minus 2 secant squared plus 2 minus 4. So you would have secant squared x minus 2 equals 0 if you did it the other way. Both those will get you the same answer, actually. So it doesn't matter which way you do it. So if it's a single, this is why this one mattered, because this is not squared. So when it's not squared, this determines that it has to match. But when both are squared, you can substitute either one. Substitute the easier one. Okay, or just pick one and do it. It doesn't matter. Okay, we're going to stop there, and I'm going to give you homework time. So we have one more lesson on this with another 2 types of things to solve that are not quadratics. So if you're like, I'm tired of those, we're done with the quadratic kinds. I gotta get my notes, just a second. Why? Oh, just a second. Okay, I'm taking these off. We'll try this again. How about 39, 40, 43, 44? So I just took 2 more out of there. And I'm not going to take off any for the Gold Star Club because there's only 4.
Yes, I was doing my warm up right now. Tell me about it.
Yep.
Just Douglas, you're gonna remind me of Paddington.
Reminds me of what?
Paddington, like the bear.
The bear.
Lovely.
In the best way possible.
Oh, good. Thank you.